example number 4 says that we have a circle with radius r millimeters, and the area as a function of r is equal to pi r squared. So find the rate of increase of area with respect to a radius of r sub naught, which is 5 millimeters. And then we're supposed to interpret that answer geometrically. So what does it mean? Well, what we're looking for is we want the rate of increase of area with respect to the radius r. So what we want is a prime of r, or the rate of change dA of area with respect to the radius, so dA dr. Okay, so this is what we're looking for. In fact, I kind of like the way that this guy's written right over here. So what we really want to find is a prime at r naught, which is a prime at 5. Or another way of looking at that for notation is we want dA dr evaluated at 5. That's what we're looking for. Okay, we get just to keep these things the same, I guess I could say dA of r naught, okay, which is the same thing as the rate of change of the area with respect to the radius when the radius is 5. So it's not too hard to do. What we're going to do is we're just going to find the derivative of this guy. So a prime of r, which is the same thing as dA dr, that's equal to 2 pi r, because the only variable is r. Pi is a number, okay? So 2 times that number and subtract 1 out. So we're using the power rule here, okay? Now what we need to do is we need to take that guy and evaluate it at 5. So we need a prime of 5, which is the rate of change of the area with respect to the radius when the radius is 5, and that's 2 times pi times 5, which is going to go ahead and give us 10 pi, and that's of course an area, so that's in millimeters squared, so square millimeters. Now what does that mean? That means geometrically that if we took a circle where the radius was 5, just like that, that's the rate of change of the area inside. If I change my radius, this little distance right here, in fact, let me do it in a different color. This little distance right here, that is dr. That's the change in r. I'll write it as delta r. So this guy right here is delta r, and the area, the change in the area, is this guy right here. And when delta r is really small, that change is 10 pi. But what's interesting about this, notice that the change in the area for delta r being really small is the formula for circumference. So what we have, an interesting and perfectly logical argument here, or relationship, is that the rate of change of area with respect to the radius is equal to the circumference at whatever that value is. So a prime of r is equal to the circumference of r, which is the circumference as a function of the radius, which is 2 pi r. So it's a pretty interesting relationship that we've got there.